Hey guys. Okay, so this recording is for our brand new unit 9.1. So the title of this is called Polar Coordinates. Okay, so up until today, many of you, I wouldn't say all of you, many of you have not seen this. Okay, we have always been graphing on these kind of coordinates, right? This is called Cartesian. Okay, in this book, they also call it rectangular. Rectangular is when we have x and y, okay? So the same thing as Cartesian. So today I am introducing you to, if you have not already been introduced in physics, okay, a new set of coordinates called polar coordinates. So in polar coordinates, this line right here, that line is, we used to call it x, now it's called the polar axis, okay? Then technically there's a dot at the center, okay? There's this huge dot at the center, or a small dot. Okay? A dot doesn't have size, by the way. A point does not have size, okay? There's a dot at the center called the pole, okay? So check this out. We are going to use angles to graph, okay? And just like any circle, this right here is pi over 2, aka 90 degrees, okay? This over here is going to be pi, okay? And this over here, again, is 3 pi over 2. So the radiance measurement of the circle has not changed. This right here is going to be pi over 6. Now, how do I know? Well, I'm taking the first quadrant, which is what, 90 degrees, right? And look, it's this particular graph is, or grid is divided or divisible by 3. So I know each one is about 30 degrees. So 30 degrees in radians is about pi over 6. So this is pi over 3. There is no mark for pi over 4. So you have to know that pi over 4 goes straight in the middle, okay? So if there are no marks for pi over 4, you make them, okay? So 3 pi over 4. Okay, and then so on and so on. You get the message, right? So if you can see it, then mark them. So make sure you divide them up evenly, or try your best to. Just like when we were graphing Cartesian, we try to make the tick marks evenly. Okay, we don't go. Okay, let me tell you what not to do. Okay. We don't go, 1 unit is right there, and then this, and then like this is 2 units, okay? That would not be okay. So make sure we make them evenly when possible, okay? That means when you're making your mark, oh, why do I keep erasing? When you're making your mark, you try your best to make the marks even, okay? So what is a polar coordinate? Polar coordinate, we are going to use r comma theta, where r is the distance from the pole, and theta is the angle formed by the polar axis and a ray. Okay, a ray means that it starts on one side and it has an arrow on the other side. So a ray usually means only one of the sides is going on forever, okay? A ray from the pole through the point, okay? And just so we have a better understanding, we will now have negative radius as well, okay? Okay, to have negative radius, okay? Negative r, okay? We are used to having negative theta because we know if we have negative theta, we are going clockwise. Now we have negative r. That means we're going to go the opposite direction, okay? So that leads me to example 1. Go ahead and go all the way to example 1. Okay. Don't worry about the other ones. We will do those later. Example 1. Plot each point given in polar coordinates. So in your homework, if you don't have these grids printed, okay, then make your polar axis, which is a line. You are giving 7 pi over 4, so you're going to need this arrow. It tells me you are about to go counterclockwise because it's a positive radian, 7 pi over 4. you will need a ray from the center to demonstrate where 7 pi over 4 ends. Okay. And then, because the radius is 5, you will count 5 tick marks. Okay, 1, 2, 3, 4, 5. And you make your dot right there. I already have these tiny circles in there, so technically I don't have to make my tick marks. But if you don't have them, then you have to make those tick marks. So that's what we need to graph out this pair, okay, this order pair. So what do I need? I need the polar axis drawn out. Okay, I need you to show me the angle, and the arrow, okay, means directional. Then you need to draw a ray. I'm repeating all of this, okay, where the angle is about to end is 7 pi over 4. Then you need to make your dots however many radius out that is. Okay, so all of those things are required. Okay, so let's move on to B. B, again, I'm going to draw my polar axis and the pole. Negative pi over 6, negative, I'm going this way. I will now draw my pi over 6, okay, because since it's negative, it's going to be clockwise. Now I need 3 units. I will not do tick marks because I already have mini circles, but I will go 3 circles out to demonstrate that is my radius. Okay. Next, I will have an angle at 0, which is right on the polar axis, aka it used to be on the x-axis. Well, I have a negative radius. Oh my, what does that really mean? Okay, a negative radius means you go the other side. Yes, you do. Okay, 1 and 2, and you make a dot. So you don't make the dot where the angle ends. You make the dot on completely the other side. So this point right here is negative 2, 0. Okay. Similarly to D, I have a negative radius again. Oh my. Okay, here's my polar axis. Pi over 3, it's all the way up here. Okay, now technically that's where my pi over 3 angle ends. Okay, but I do not make my radius there. I draw another ray and I count 6 units out. So let's see, 1, 2, 3, 4, 5. Only 5 there, so make another one. So extend this. There you go. So that's my radius of 6. So notice again, I do not, I'm repeating, do not make the radius dot on the angle. You make it on the other side. Okay.
All right, guys. So example 2 says use the problems in example 1 and find other polar coordinates, which is always denoted as radius, comma, theta, which is an angle of the point for which. So we got 1 eye, 2 eye, and 3 eyes, and these are different conditions for our example 2. Okay. Now, so 1 eye says all of the points in example 1. Now I want you to find a positive radius, and the angle is now restricted in between negative 2 pi and 0 inclusive at negative 2 pi. Now, as you know, example 1 had 4 parts, so why don't we make 4 little boxes? How about this? Separate these, okay? And because we have 4 parts in example 1, I want to have room for all 4, okay? So example 1, A, B, C, and D. Okay, let's go and find example 1A. 1A, the original was already a positive radius, so we got positive radius check, and the angle was positive 7 pi over 4. But the restriction, for example, 1i is now it wants us to change it to a negative radius. So all we do is, remember, we still have to end up at exactly the same spot, okay? So for us to end up at the same dot here, we just have to go counterclockwise. So that will still give us the positive radius of 5, but now we're gonna have a negative, so 5, negative pi over 4. This polar coordinate will still give us the same exact location. Okay, now let's go to B. In B, again, we already have a positive radius of 3, and we already have a negative angle. So we don't have to change anything on B. So we will keep it exactly the, was it a pi over 3 or pi over 6? Negative pi over 6. Maybe that would be helpful if I just write all of these down, huh? So I don't have to go up and down. That's what I'm going to do. So hold on tight. 5, 7 pi over 4, that was A. A, 5, 7 pi over 4. And B was negative, no, that was positive 3. B was positive 3, comma, negative pi over 6. And C was negative 2, comma, 0. And D, so this way I don't have to go up and down. D was negative 6, comma, pi over 3. All right, there you go. So now that we have those, let me get the green pen again. All right, let's move on to, okay. Now C was negative 2, so that was a negative radius. And remember, example 2(1i) wants us to have a positive radius and a negative angle. Now we do want to get to this dot over here. So for us to get a negative angle, we will go a negative pi. And all we have to do, if we go a negative pi already, then that is our negative angle. And if we do a positive 2 radius, then we don't have to go the other side. So we will write positive 2 radius. So this 1i here, all of the radius got to be positive and all the angles got to be negative, but it should still give us the same exact location, okay? Then we have D, which is negative 6 comma negative 6 comma positive angle. Well, we don't want a positive angle and we don't want a negative radius, so we will go clockwise to get a negative radius. Clockwise to get a negative angle, and then just stay on that ray. So now we are going to write positive 6 and negative 2 pi over 3, okay? So that's positive 6 and negative 2 pi over 3, just like that. Now on 2i's, it wants all of the radius to be negative and all of the angles to be positive. So we will draw out our lines. I'm gonna go get blue and make all of my lines here blue to separate my A, B's, and C's and D, okay? Just like that. A, B, C, and D, there you go. So A, B, C, and D. A, B, C, and D. So what I'm going to do here is I'm going to work out A and B with you for 2i's and 3i's, and I'm going to leave C and D for you guys to try on your own. So next, I will get a green pen. Okay, so let's do A and B on both 2i's and 3i's. A says 5 comma 7 pi over 4. Well, 5 is a positive radius, and 2i's want us to have a negative radius, okay? So what we need to do is we need to go a positive angle, okay? Mind you, we have to go a positive angle and a negative radius. Negative radius meaning that when you're drawing that ray, the dot has to go the opposite direction. So if I were to go completely opposite direction of what that doesn't look like a very good ray there. Okay, so what if I go, here's the opposite direction of what I already have. What if I go positive angle here, but I can't make my 5 radius there because it has to be a negative 5 radius. Would you agree? But that's okay. If I go opposite of that, I'm going to end up at the dot that was supposed to be. So that angle is perfectly fine. And so this is a pi over 2. This is a pi over 2. So that means that's 3 pi over 4. So I'm going to go up, comma, 3 pi. Oh, I'm supposed to write that on A. I lie. 3 pi over 4, just like that. All right, B, again, we want a negative radius. Currently, B has a positive radius, and it has a negative angle, so we don't want either one of those. And similarly, if we want the dot to be exactly where it is now on B, I'm just going to go and draw a ray opposite of where it is now. I think that's, oh, that's some ugly, right? No, and that's not even straight. So let me turn my paper. There you go. So if I want to go all the way there, okay, so let's see, this is a pi over 2 here. So that's going to be 2 pi over 3. Okay, so that's 2 pi over 3 currently. Is it 2 pi over 3? Let me check, sorry. This is a pi over 3. No, that's 5 pi over 6. I lie. So this right now is 5 pi over 6. Okay, so that's 5 pi over 6, but I want a negative radius. So that's perfectly okay, because then if I go to the blue, so go the opposite. So if I go here, that's where I want it to be. So we do have a negative 3 comma 5 pi over 6, just like that. So now I'm going to jump over to 3i's and do both of those again with the restriction of 3i's. On 3i's, it wants a positive radius and it wants over 1 revolution. So I'm going to erase all my greens here. Over 1 revolution means a circle and a little bit, okay? Which is not a bad idea. So here's 1 full circle, but it wants more than that. So I'm going to go wee another time. Well, full revolution is 2 pi, and we're ending at exactly the same spot on example A there. So now I'm just going to do plus 7 pi over 4. So as you can see, 2 pi is 8 pi over 4 plus 7 pi over 4. So that's 15 pi over 4 is our angle. Okay, so our angle is 15 pi over 4. 15 pi divided by 4. Now it wants a positive radius. We already have a positive radius on 5. So now we're just going to copy the 5 back down. B, similarly, it wants exactly the same spot and a positive angle. So I'm going to go, well, that's 1 full revolution and a little bit. Okay. So again, a full revolution is 2 pi and it wants a positive, excuse me, it wants a positive angle. So as we know, that's 2 pi with 1 full revolution. We know the reference angle is a pi over 6. So now we are left with 11 pi over 6. So if you have a common denominator, this is really 12 over 6. So now this angle is 23 pi over 6 is the angle. 23 pi over 6. Okay, now the radius is positive, so all we do is we're going to copy down 3 because it was already positive. Now I want you to take a minute to do C and D for both 2i's and 3i's. So example 2, 2i's, part C here. Hopefully you guys got -2 comma 0. And part D, you got -6 comma positive pi over 3. Remember, this restriction, all angles got to be positive and all radii got to be negative. Now for 3i's, part C, hopefully you guys got 2 comma 3i. And D, you should have gotten 6 comma 10 pi over. Okay, before we start example 3, let's fill out this piece of information right here. So make sure you roll your paper all the way back up or flip all the way to the front page. Conversion from polar coordinates to rectangular coordinates theorem. If P is a point with polar coordinates r comma theta, the rectangular coordinates x comma y of the same point P are given by, to get x, it's always radius times cosine of theta, and to get y is always radius times sine of theta. Now let's look at this first triangle. Let's make that. There's a right triangle. This is y, this is x. And as you know already, cosine, let's prove it, right? Cosine of theta, it's always adjacent over radius. Well, in polar coordinates, it's always r equals. Wouldn't you agree? So if I were to multiply both sides by r, I would now have r times cosine of theta equals x. Okay, so that's why, that's how we convert it to that. Now, how about sine? Same thing. Sine of this angle is going to be opposite, which is y over radius. And again, we can solve for what y equals by multiply both sides by r. So r sine of theta equals y, and that's how we get those two formulas. Now with a circle, it's always x squared plus y squared equal radius square. So if we take the square roots from both sides, it's radius equals square root of x squared plus y squared. But remember, when you take a square root, you technically should have a positive or negative. But if you're just dealing with a triangle, radius can't be negative. Now again, if you're dealing with a measurement of a length, it can't be negative for radius. But in polar, remember, radius is just like directional. Just like in trig, right? Negative angle is just directional of clockwise. So tangent, from what we study in Algebra 2 trig, it's always opposite over adjacent, or y over x. So for us to figure out how to get theta, which for us to use later if we were to go back to polar. So theta is always tangent inverse of then y divided by x in quadrant number 1. Okay, so in quadrant number 1, we don't have to do anything special because we do not need to worry about the tangent inverse restriction. It may be a little bit different when we go to the other quads. So again, to get radius, it's always the square root of x squared plus y squared. Similarly, tangent, it's always going to be y divided by x. So to find theta, we take tangent inverse. But guys, this theta is in quad 2. When you borrow tangent inverse to solve, right, it's limited to you to quad 1 and quad number 4. In quad 2, tangent inverse is negative. So we have to make sure that we bring it back to quad 2 accordingly. So when you borrow the calculator and you punch it in and it's negative, it said, oh, wait, you're in quad 4. But my answer is supposed to be in quad 2. So how do we get from quad 4 to quad 2? We add half of a circle, which is we add a pi. So we add pi if theta is in quad 2. Okay, if theta is in quad 2. So again, we add half a circle if our original dot or point is in quad 2. Similarly, what if the point is in quad 3? Well, when we borrow tangent inverse, right, to solve for it, it can only give us answer in quad 1 and 4. In quad 3, tangent again is positive, so we have to, when we borrow a calculator to solve it, it spits out an answer that's less than 90 degrees or less than pi over 2. But we have to make sure we put it back in quad 3 where the original, remember, the original dot was, so we go and add half of a circle, which is pi again. So we do this if the point or the angle, so we just use the point, is in quad 1, 2, 3, 3. All right, now we have one more. What if the point is in quadrant number 4? If it's in quadrant number 4, we don't really have to do anything special because tangent inverse will immediately spit out an answer in quad 4, so I don't have to worry. So this is going to be r squared, so square root of that is just to be r. And so theta is going to be tangent inverse of y divided by x. And again, we do not need to do anything special because tangent inverse will immediately give you an answer in quadrant number 4. Okay? Now let's go and practice example 3. So in example 3, it says use the polar coordinate. You know what? This should have use the polar coordinates from example 1. Find the rectangular coordinates of each point. So I went ahead and copied down all of the polar coordinates from example 1 here. That way I don't have to go back and forth. And now I want to get a different pen, a blue pen. Okay, let's do it. Rectangular coordinate meaning that we're looking for x comma y. Okay, so earlier we just went over x is always cosine, r times cosine of theta. And so let's find x. Radius is 5, so that will be 5 times cosine. Angle is 7 pi over 4. X equals 5 times 7 pi over 4 is quad 4, so cosine is positive rad 2 over 2. So x is going to be 5 rad 2 divided by 2. We can do the same thing for y. The formula for y is y equals r times sine of theta. And again, r is 5. Theta is 7 pi over 4. 7 pi over 4 is going to be in quadrant number 4. Sine is a negative rad 2 over 2. So y comes out to be negative 5 rad 2 all over 2. And now I just have to put it together as an ordered pair because it's a set of points, a set of coordinates. So 5 rad 2 all over 2, comma, negative 5 rad 2 all over 2, and that's my final answer. Okay, I'm going to do, I will do, how about this? I will do C and D, and I'm going to leave B for you to try. Okay, so right now go ahead and hit pause, do B for me. Once you're done, unpause, and then listen to C. C, same thing. I'm going to do R cosine of theta. R happens to be a value of what? Negative 2. Cosine 0. Well, cosine 0 is going to be cosine 0 is 1. So guess what? You get a negative 2 back. And y is R times sine of theta. Y is, radius again is negative 2. Sine of 0, oops, 0, not theta. Well, sine of 0 is 0, so negative 2 times 0 is now 0. What? It's the same exact answer as polar and rectangular? Yes, it is. Okay? Yes, it is. All right, now I'm going to go D because remember your job was to do B. So x equals R cosine of theta. R is negative 6 cosine of pi over 3. Then x equals negative 6 cosine of pi over 3 is going to be 1/2. So that will give me a negative 3. Y equals R sine of theta. R again is negative 6 sine of pi over 3. Then that will give me negative 6 times radical 3 divided by 3. This will give me, rad 3 over 2. And this will give me negative 3 rad 3. So put it together as an ordered pair, negative 3, comma, negative 3 rad 3. Box that up. So hopefully by now you should have an answer for B. Did you come up with 3 rad 3 all over 2, comma, negative 3 over 2? Okay. Hopefully you guys have a matching answer for B. If not, make sure you ask me to go over it in class for you. Example 4 says, the rectangular coordinates of a point were given. Find the polar coordinates of each. So now we're going to go backwards, right? So previous example wanted us to find the rectangular, given us the polar. Now we are given the rectangular, and our job is to find the polars. So here are the guidelines or the steps for converting from rectangular to polars. Step 1, always plot the point first. So we're going to cross this out because we did not, I copy and paste this from your book. So our examples a little bit out of order. Step number 2, if x equals to 0 or y equals to 0, use your illustration to find r comma theta. And again, cross that out. Okay. Step number 3, if x is not 0 and y is not 0, then use the radius formula, which is the square root of x squared plus y squared, to solve for it. Step number 4, to find theta, first determine the quadrant, just like earlier, for example 3, right? Different quadrants, you have to either add a pi, half a circle, or not. So theta is always tangent inverse of y divided by x, and we don't do anything if we are in quads 1 and 4 because tangent inverse is restricted in 1 and 4 naturally. If you're in quad 3 or 2, then you have to add half a circle, which is pi. So let's practice. Are you ready? First, make sure you sketch it out. Okay, plot it out. This is rectangular, so 0, 4, 0 is x, 1, 2, 3, 4. It's right there. That tells us if I were to draw a circle, this tells me the radius is immediately 4, and the angle is just going to be at pi over 2. So look at that. I don't even have to do anything and to get the answer right away. It's always radius of comma theta. Radius is 4 and theta is pi over 2. Bam. Look at that. Easy peasy. Then let's sketch this out. You have an x value of 3, 1, 2, 3, a y value of -3, 1, 2, 3. So my sketch tells me I'm in quadrant number 4. Well, in quadrant number 4, as you guys already know, I'm going to use tangent inverse. So theta equals tangent inverse of y divided by x. Well, y, it's going to be a -3, x is 3, so that's going to be tangent inverse of -1. Whoa, that's cool because that's a negative pi over 4. Okay, so I got my theta. Now let's find the radius. To find the radius, we will use r equals the square root of x squared plus y squared. Radius is going to be x squared, 3 squared would be 9, plus the quantity, which is -3, squared is also 9. So that will give me the square root of 18. 18 is going to be simplified that down to 3 rad 2. So I have an answer. Remember, it's always radius comma theta. So radius is 3 rad 2. Theta is going to be a negative pi over 4. I need a bit more space in that box. There you go. Now, would it be okay if you use positive angle? Of course. Okay, I'm going to write down here. Or what if we write 3 rad 2 comma 7 pi over 4? Why not? I can totally do that. If I don't choose to go clockwise on my angle, I can go counterclockwise. I would still get to the same exact dot, okay? And you can even get creative, right? Would you agree that you can even have an angle in quad 2 and then just make the radius negative? Of course, all of that is possible. So what I'm saying is that on a test, you can technically have infinitely many different answers. So it doesn't have to be what I have written here or what the book has in the back of the book. I mean, what the book has in the back as an answer. All right, you're on C. Let's draw it out. It's a -1 for x and a negative square root of 3. Well, square root of 3 is going to be in between 2 and 3 in terms of, in between 1 and 2. Between 1 and 2. Because square root of 1 is 1, square root of 4 is 2, and 3 is right in between 1 and 4. So somewhere here is where my dot is, right there in quad 3. Well, let's figure out my angle. Theta equals tangent inverse of y divided by x. Y is negative rad 3, x is -1. That's definitely a negative, and a negative is now positive, so that's why it's in quad 3. So I would now have 4 pi over 3, right? Because that's the angle in quadrant number 3. Now let's find radius. Radius is the square root of x squared, which is the quantity of 1 squared is 1, plus the quantity of negative rad 3 squared, which is now positive 3. Oh, I made a radical sign way too big. So that will give me a value of 2. So 2 comma 4 pi over 3. Yep, totally okay to have. What if I write 2 comma and go clockwise, just like that? Of course you can. -2 pi over 3. Sounds good to me. You can also have that. And again, you can have different answer and still be okay, as long as your point still brings you back in quad 3. And that's example 4 for you guys.